So today we're going to talk about graphing linear inequalities. So this is number 9 here from your packet. We're going to start by just graphing our y-intercept and counting out our slope. So we're going to start here at 3, our y-intercept, our constant, and then our slope is our coefficient of x. So from here, we're going to count out our slope, which is really 2 over 1. 2 over 1 and 2 are essentially the same thing. So from here, I'm going to count up 2 and right 1, my rise over run. Down 2 and right and left 1, down 2 and left 1. And you could continue that on for your whole graph. So now normally if we are graphing a linear equation, we would just simply connect these with a line. But since it's an inequality, we have to test and see if we would have a dotted line or a solid line, and that's based off of this inequality symbol. So what we do is we're going to test a point on the line. We're going to plug it into the inequality and see if it's true or not. So I'm going to test this point 0, 3, which means I'm going to plug in 3 for y and 0 for x. And then I'm going to see if I get a true statement. So if I read it out, it would make sense. 3 is less than or equal to 0 plus 3. 3 is less than 3. Is 3 less than 3? No, it's equal to. Not a true statement. So since these points would not be included in our solution set, we're going to draw in a dashed line or dotted line. And again, that's because these points would not be included in our solution set. Now we have to shade the appropriate side of our graph to show which side of our line is the solution set. Where are all the points that would be solutions to this inequality? So I'm going to test the point 0, 0 because it's very easy and it's not on my line. So I'm going to plug in 0 for y and 0 for x and see if I get a true statement. So this point is going to be representative of all the points in this region on this side of the line. If I were to test a point on this side of the line, it would be representative of all the points on that side of the line. So 2 times 0 is 0, and then 0 is less than 3. 0 is less than 3. That is true. We got a true statement. So that means 0, 0 is a solution. So I would need to shade in everything on that side of the line, representing the solution set. I could pick any point on this side of my line, and it would give me a true inequality statement. It is a solution because it makes a true statement.